YouTube viewers. I know it's been a long time, but I assure you I have been working on this thing since the last time of the video. It's been a rough one. I've got an interesting problem that's really been taxing my brain to fix this problem. Anyway, so let's talk about this a little bit, and we'll continue. I'll be able to show you what my journey on fixing this actual problem. So if you looked at the last video, you will remember that the machine is actually, the tape is actually working. It's transporting the tape from one reel to the other. So the spooling motors are working beautifully, and I can rewind, I can fast forward, I can locate the tape, I can shuttle it on there. I can do everything in moving and handling the actual tape, okay? What I can't do is play the tape, all right? The pinch roller will engage, the capstan will turn, it will play at a really fast speed one time, and then stop, and then I'll stop it and it won't play again. I'll have to shut the machine off, turn it back on again, and I can get away with that one play thing. But the key is when it's running, when it's playing at a very fast speed, and if I change the speeds, nothing happens. It stays at that fast speed. Now, you got to remember this capstan motor does a lot of things. I was thinking, well, it's pretty simple, pretty thing, but it does a lot of stuff. It does, not only does it do 3 speeds that it's synced to, okay, but it does a vary speed that will go from 0 to whatever, high speed. It does a reverse play besides the forward play, and in the edit mode you can move it around the heads just like you could shuttle the tape, but you're going to move it with the pinch roller engaged, so you're actually moving it on the heads. So none of that is working correctly, all right? But the tape handling, the shuttling, is working fine. You got to remember, on tape decks like this, those motors, the big motors, the spools, are just handling the tape. If you had let's say a 6-foot piece of tape, you could put it in there on the pinch roller and it'll play right across. You don't need those things. Those spools behind you are mainly to handle the tape, to take it so when it plays that 6-foot piece of tape, it doesn't just fall on the floor, it gets rolled up onto the other reel. It comes from this reel to that reel. And so that's really what the spooling motors do. Now that's all working. It's this play that's not working. So let's take a look at how I've gone about looking for this problem. Okay, so my first step in this is to analyze what actually is going on. So when it's in play, when I press the button and it goes into play, the play light button will come on, solid, okay? Tape will start playing at a really fast speed, okay? And the tensions are correct, because if I did that play at the beginning of the reel or at the end of the reel, it still did the same thing. It still runs across correctly. Now, all the time I've been doing stuff on this machine, I never paid attention to the capstan motor, what it was doing. It was turning, so I figured it's okay. But now, knowing this, I'm looking at this and I'm going, all right, I put it in play and it's going real fast. Could be doing 30 ips. It could be doing faster than that. But I hit the selector to change it down to 15, still keeps going. Hit it down to 7.5, still going. The LEDs are showing me that it's changed speed, but speed hasn't changed. So the capstan motor's still running at the same speed. So then if I hit stop, okay, and I hit play again, now it doesn't go into play. The engagement, the rollers come in, but it doesn't go into play, and the play light starts flashing now. So my theory here, I'm thinking, is the machine knows that play speed is not correct. It knows that the play speed is not correct, so after the first time when it tried it, once it got a pulse and it said, oh, okay, this is what speed it's at, it said, from now on, I'm not turning on because that's not right. That's not the right speed. So with all that information, I feel that it's somewhere in this capstan, and I have never looked at the capstan stuff from the beginning because I thought it was working. I saw the capstan motor turning, I just assumed it all was working. So the capstan motor involves three different things, about 5 different things. Besides the motor itself, okay, there's a little board which is the tacho sensor board that senses the what the motor speed is and sends that out, okay, to the capstan control board and the capstan interface board. Those 2 boards are located down below, the capstan interface, capstan control. There's also the capstan motor driver board, which is up on top, which is actually driving the motor at whatever speed it's supposed to drive it at. So those 1, 2, 3, 4 boards and the motor, those 5 things all control the capstan itself. And that's what's really important to get them going. So now, the easiest solution when you're looking for something like that is go into the middle and try to divide the problem in. But in this case, I can't get to those 2 boards down below easily because I don't have extenders for that. But I can get to that motor drive board. So let's take a look at the motor drive board because I can get on there and probe that board. All right, now let's take a look at the schematic of that board. Okay, this is the schematic of the capstan motor drive amplifier. I selected this because it's easy to get to. I'll show you that in a second. But if you want the actual circuit description, this is what I went off of. I'm going to put this on the screen right now, and you could pause the video and read it if you'd like. But after that, let's get back to where we're at. So what's going on now is I made, after reading that description, I've made a few notations on here so I could understand what to look for. All right, so one of the things down here is right here is 76 kilohertz. Comes from the MP unit tape deck control. I figure that's something that's really important into this thing because that sets the speed everywhere and the timing of everything. Okay. The other thing, this is going out to the actual motor right over here. This is the phases going out to the motor. Okay. And down here, one more thing here is the rotation direction bit. Comes from the capstan control unit. And this says either go forward or go reverse. It tells it what to do here to the motor. Okay? The motor gets its power from up here. The main power comes in right here, okay, from the power supply, around 50 volts, and it goes through this circuit right here, which is a regulator circuit, and it's being regulated by this right here, 0 to 10 volts, which is coming from the capstan interface. So this drives in here, regulates this, and then puts out -5 to 40 volts dependent upon the speed. So this voltage right here is going to vary dependent upon this one right here. And that's the voltage that's on these transistors that are driving out to the actual stators of the motor like that. Okay? So this is what I got going. So now I go on to the actual board, and I need to look at these things. So the first thing I went and took a look at was this 76 kilohertz. So I'm able to clip my probe right here on this resistor, okay? And I could see I'm getting a 76 kilohertz square wave. Perfect. So I know that this is good. This section coming in here is good to 76K. So the next thing I thought I'd do is, let me look at this 0 to 10 volts thing. So I put the machine into play, put my probe right here on this resistor, and I measure 10 volts DC. I change the speed on the unit down to a slower speed. Still 10 volts DC. I change it down a little slower, 7.5, 10 volts DC. I put it in very speed, still 10 volts DC. So to me, this is not correct right here. That 10 volts DC is what's making this thing run so fast. Because it comes in here and it probably puts out 40 some volts. I didn't measure it, but this 10 volts DC is a problem. So what we got to do is we got to look at the next thing here. It's from the capstan interface, it says. So what we're looking for is this signal line, which is called AN-CSP-DC. I think that stands for analog capstan speed DC, which makes sense, right? So this is the signal we're going to look at on the capstan interface card. Okay, before we look at that card, let's take a look here why I'm going to the capstan motor driver board. As you could see, it's right there, and it's pretty easy access. And this is why by just flipping up the lid, I could actually put the scope on it and easily access this circuit board versus other boards that it's a little harder to do. And this is a close-up picture of that circuit board right there. This is the capstan motor driver or motor driver amplifier PCB. And over on the right-hand side, I'm going to point out here, is where the power goes in. That is a 6-way connector, but they're only using 2 pins. There's only 2 wires going into that 6-way connector. And the 2 spots that I was talking about, where we were looking at it, 76K, there is the resistor right there that has the 76K on it. And the other resistor is the one where we're going to look for that, or we just found that line there, the 0 to 10 volts line, the AN-CSP-DC. Okay, so that's the other resistor right there. Okay, this is the schematic for the capstan interface card. Now, it's pretty complex. I will admit, I'm pretty much not sure myself a lot of this stuff. So first thing I'm going to do is, like the other one, I'm going to put the circuit description up on the screen. And feel free to pause the video if you really want to read everything about what's going on this card. Other than that, let's look actually at the card. So there's 2 things mainly is anything with a TD prefix. If you see up here, TD, these are coming, these have to do with the MPU tape deck control card that interfaces into here. So the data going in here or in and out of here via the MPU tape deck control card. That's the data into this thing here. Anything with a TC prefix, which you'll see down in here, okay, is data going in and out of the capstan control unit card. All right, so the TD, tape deck control, TC, capstan control. All right, now let's take a look at a few of these things right here and see what goes on here. So basically what's going on here is this data goes in here, okay, and then runs over here through the data that's shared throughout this thing, the processors. And this is an analog to digital converter. And this is our voltage, okay? This converts it to a DC voltage here, all right? And comes out over here, right there, okay? That is the signal, AN-CSP-DC. That's our analog voltage to the other board that's telling it 0 to 10 volts, what speed to run at. Analog after this converter right here. Okay? But understand this is getting controlled by this data going in here and here. So what we really need to do is look at what else is going on this card right here. All right? So let's take a look at over here, important ones, okay, this one right here, TD-TCM1 and TD-TCM2, okay? These are produced by the tacho sensor PCB on the motor, and they're square waves with a 90 degrees phase shift, just like we've seen on the optical disc, but this is done differently on the capstan motor. So they feed, and you can see it by the little arrows, the way this hex inverter is going, they're feeding into this board right here, okay? Those are actually square waves going into it. Now, there's some signals coming out of this here, the TC-TCM, TCMV, and let me see where that's at. That's right in here. And TC-TCMV1. Okay? Now, these are signals coming out. Notice the inverter going this direction. Right? And TCMV is used for synchronizer. And the other one is used for the speed via the capstan control unit. So this is coming out and telling us, okay, this is going at the right speed and whatever like that. All right. Now let's look at two more signals here. We have this one right up in here, which is TC-TCDIR, directional rotation. And that's used for the synchronizer. And we have one more right in here, which is TC-CDIRI, directional rotation, and that's going telling the capstan control unit what direction that's going in. And all of that's coming from this IC here, IC 9, that actually tells it this stuff like here. Okay? Now, so what I'm going to do here is I'm going to set up and look at these signals here. In addition to these signals here that I've just mentioned, okay, what we'll also do is we'll actually look at plus 15, minus 15, plus 6.5, and this is the ground. So we'll set all this up to look at these signals. We know that this here, I mean, I could look at this thing right here, but I know 10 volts is coming out of this point right here, all right? But the question is, why is 10 volts coming out of here? I mean, this IC is not shorted or nothing like that. It's not a direct short to ground. Well, it can't be because it's only 5.6. But anyhow, this is putting out that 10 volts that's not varying. So let's figure out what over here is causing this thing to happen like that. Okay, so this is the actual capstan interface card, and you can see the big microprocessors right there. In the center sort of section. And so what I really need to do is set up those 10 points that I just pointed out, solder my 10-way ribbon cable onto those 10 points, and then it'll go out to a little connector board where I can actually use the scope probe, because this is going to be plugged into the card cage, and I won't be able to get to any of this stuff right here. All right, this is the 10-way ribbon. Uses resistor color code, brown being number 1. And I've soldered it on 10 points. And then it's going to go out to a little board that I made that has headers on it. And that's it right there. So you can see I've just used the resistor color code and come down. And in this case, I've labeled what I'm going to measure. I've labeled where those things are going to. So that's what I'm looking for. TCM1, 2, like that. The power down at the bottom. So now it's very easy. I could get my scope, including the ground, and just go to these points with the machine running and see what happens. Okay, so as you can see, I have my little extenders right there. I'm able to clip my ground from the scope probe on ground. And the first thing I did was to check the voltages, and they were all good. Those voltages were fine. So then I started at the top and worked my way down and hit TCM1, TCM2, and whoa, when I hit TCM2, nothing. So as soon as the capstan motor starts turning, TCM1 It's got a square wave on it. But TCM2, nothing. Not a single thing. Dead. So there's no sense to go any further because those are two critical signals to the function of this thing. So both TCM1 and TCM2 are coming from the tacho sensor electronic board via the capstan tape driver. They just passed through there. But so let's look at the tacho sensor electronic circuit diagram. Okay, so this is the schematic of the tacho sensor electronics PCB, which is attached to the back of the capstan motor itself. It's actually screwed on back there, and I'll show you a picture of that later. Like the other ones, I'm going to put on the screen right now the actual circuit description. So feel free to pause the video if you really want to read all the information about it. But let's get on with it. So this schematic may look a little simpler. However, it is quite complicated as usual in this thing. So basically what's going on here is we need to produce two signals, okay? The TCM1 signal, which is up here, and the TCM2 signal, which is right here, okay? And so those two signals are coming out of here. You can see them coming out of there and there, all right? And those are square waves, remember, 90 degrees phase. Now, what happens here is there's not an optical disc inside the capstan motor. There's two plastic discs, and they're set up so that they're they're like 90 degrees out of phase, but they're connected with a bunch of stuff, and they form a capacitor in there. And the capacitor is basically tuning right here. This is where it feeds in, here and here. You see them right there and right here. They feed that in, and that capacitor, okay, in parallel with this inductor right here that's on the board, okay, form this tuned circuit. And this here is a 5 megahertz oscillator. The 5 megahertz oscillator feeds into these two ICs here and compares it to this tuned circuit to there. And as this thing changes, it now can sense the speed direction and the speed and direction from this tuned circuits, these two things here. So the output comes out like this here. It feeds into like a sort of buffer amplifier. It then goes through this little circuit here, which is like a Schmitt trigger that actually turns this tuned output, which is just a sine wave, turns it into a square wave. And then this actually defines it a little bit more, the square wave, till it comes out over here. So coming out over here, we should have square waves like that, and then over here like this. And remember, what we're not getting is TCM2, which is this one right here. Oops, sorry, that should have been up here. Okay, so that's TCM2 right there. And hopefully that makes sense. Now, same thing here is we're going to go and look at those boards, this board here, and see if we could find what's causing this, not TCM2, right here, not to come out. I'm not getting any signal out of this thing here. Okay, so this is that tacho sensor electronics board that we just looked at the schematic. And you can see on the right-hand side, those two large ICs are the same two ICs we were talking about in there that are causing, or with those coils, see the coils right next to them, that are making that tuned circuit, okay? And then they go through these other ICs like that and eventually come out with that TCM 1 and 2. And those TCM 1 and 2 are going to come out on those wires on the far left there. They actually go onto actually wires. Those connectors go to the actual capstan motor. That's those stators and different things that we were talking about. You know, how it senses these various parts of it. So those all plug, the motor plugs into this. This board sits on the side of the motor. But those two signals come out on those wires down over to the side, and they go into that 12-pin connector that you saw on the previous board, that 12-pin connector up in the corner, the Molex, okay? And they then go directly from there to the ribbon cable, and the ribbon cable goes down to the card cage, and the card cage then goes into the interface, the capstan interface card. So it just kind of passes through there. Now, when I looked at that 12-pin connector, I saw all this corrosion in there. So I got all excited. I said, that's the problem. Those two pins that are in there that have TCM 1 and 2 on it probably are corroded. TCM 2 is probably corroded and not going through. So I ordered a new, I couldn't depin this thing. I tried everything, every depinning tool I had, and you know what, it was easier to just order a new connector and new pins. So I'm going to cut this off, put new connector on here, put all the new pins in and repin the connector. This way I know I got solid connections to not only the TCM 1 and 2, but to the motor itself. Now, while I was waiting for that connector, I decided, well, let me go check if I'm getting signal before the connector. So I kind of straightened it back there and checked it, and I wasn't getting any signal into that connector for TCM2. So I had a closer look at the actual capstan, the tacho sensor electronics board. And this, if you look up here, this is what I found. Okay? There's a little bit of corrosion going on right there, and that pin broke off the capacitor. It's not touching. I separated it a little farther than it was, but it was not touching that capacitor right there. So if we have a look back at the schematic of the tacho sensor board, you'll see that that cap is C2, right? Or I can't read the number from here, but it's the circled one in the center, 2.2 microfarads. That's the cap that's broken, and you could see that's the main signal of the TCM2. So that's probably our problem. So while I was replacing that cap, I decided I'm going to replace all of the caps in here because it's so far buried in there. And this is the circuit board after I've replaced all those tantalum caps. And I've also replaced the IC sockets. I just didn't trust the way those sockets. I like these ones better, these collet sockets. They seem to grip the IC pins much better than the other ones. So I put in all new sockets, which are actually gold pin sockets, and put in all new 105 degree caps in this circuit. And then I'm going to put on that connector that I told you about, and then we'll see what happens. Well, I'd like to tell you after all of that it's working beautiful. However, that's not the case. Matter of fact, is it not only not working, it's not working as good as it was working. So, obviously that tells me I did something wrong somewhere there in that stuff. And, but we're out of time on this video. It's really way too long at this point. You're going to have to come back next week or next couple of weeks and see what's gone on here. So, please, as usual, please subscribe to the channel. Thumbs up if you enjoyed the video. Click on the bell for notifications, and I'll see you back here in a week or so. Thank you.